Okay, this video will cover the LAN-Caster client code and just give an overview of that. Concentrating really on two classes, the client class and the ClientMap class. And the reason to concentrate on these two is these are the ones you're most likely to subclass for your game. Now, the client class, you would subclass that at the game level in your game directory. And then the client map, you can subclass either in the game directory or actually per map, you can have a subclass client map. And we'll just show a quick demo or a quick example of that from the demo game. All right, but let's actually dig in before we do that on the start client. And we'll go right back to the very beginning of how the client starts. So if we look at, for instance, the run demo bat file for Windows, it actually starts the client by running Python and then running the startclient.py file. And briefly, I'm just going to have a look at that. You can read the details. But this file does very, very little of consequence, but it does handle all of the command line arguments. So I'm in the source directory of LAN-Caster and I'm in startclient.py. And what you're seeing here is all the command line arguments that it can do. So when you type in -H on the command line to get the help text, this defines all the help text, what arguments can be given, and takes care of all that. And then the work of all of that to parse all those arguments is here. So that's the start of this file. Its main job, though, is to actually load the client and then run it. And I'm just going to talk a little bit about loaders. If you read lots about Python, you'll know about import. So import the argparse module from the engine log module, import the log function. To load the client correctly, let me just move this out of the way. What we're actually doing is we're using a load module. So this is nothing particularly fancy, but what it does is it's like calling import for the client .py, except it's going to look in particular places. So it's going to see if there's one in the game folder for the particular game that we're running, and if not, it'll load the client from the engine. And then once it gets that module loaded, it's just going to call run on the module. So I'll talk about subclassing later, but for now, let's just look at the default way it would work, assuming that we're using the client module from the engine. So if I open up the engine folder, and I look at the client class, and I'm not going to read things to you that you can read for yourself, but this will describe to you in the client class. So again, I'm in source engine client.py. It'll describe to you what it does. There's some good comments here. You can read through what the client's responsible for doing. The two functions I'll talk about, though, today in a little more detail is the init and the run function. So in the init, there are some things here. The first one is that we do a global reference to the client. So we create a global variable called client and we put that into itself. In this way, anything in the client can actually reach into this global variable and find a reference to the instance of client. And there can only be one client object that you instantiate. I'm just going to turn that off as well to make it easier to see. And so I'll skip over some of this. It's not that important, but the first thing we'll look at here is what are the attributes that are inside the client object. And here you can see many of them being set up, and most of them are just being read from the command line arguments and stored so that later you can reference them. So if you're in the client, you can reference the player display name, the window width and height that's been requested, those sorts of things. Okay. We're going to set up some default values. Again, I'll let you read the comments for these. And then we actually get into the network setup. So there are some options there on how to set up the network, but at some point through this process, we actually, and I'm actually going to scroll down, you don't need to understand all of this, but at some point in this, we call join server, and this is the key one. So this actually gets a reply from the server and tries to join. If we don't get a reply, then we can't join. Otherwise, we actually get our player number from the server. So when we get a reply message from the server, it's got an attribute called player number, and we store that in our object, in our client object. That join reply message also gives us some time synchronization. I'm not going to go into the details of that, but we need to synchronize time with the server. So that's what that is doing. Checks to see whether the server is in test mode. If the server is in test mode, then we make sure that we log that and we know that we are also in test mode. So again, that's why you can put the -test on the command line for the server, and then the client also shows all the text saying it's in test mode. It comes back in that join reply message. Then it says join server was successful if we joined the server, and then we can go off and open our window and do all of that work. So this is where we actually take Pygame, which is our graphics library. We initialize Pygame. We turn off audio at this point. So, I mean, if we want to add audio to the engine, you would not do that. You would actually do the audio setup correctly. You set up your screen right there. And you get your window open. So this call right here will actually open the window. So this is still in the init function. And then after that, we actually load our tile sets and we load our map data. So we get those and we store those again inside the client object. So that will all be loaded. And that's the end of the init. So at the end of the init, we have communicated with the server, joined the game, we've opened the window, and we've loaded our tile sets and our maps. Now, one of the things I do want to just show when we talk about communication with the server is a little bit about how the messaging works. And I'm not going to go into detail in this video. I'll do it in another one. But there's a file called messages.py. And if you look in messages.py, it has a definition of what all of the messages are. So we talked about a join request, so the client would have sent a join request to the server, and that contained a game, which is a string between 1 and 32 characters long, and a player display name, which is a string between 1 and 16 characters long. And the server would send back a join reply message with your player number, which is an int, the server sec, which is a float, so that's the thing we use for time synchronization, and whether or not the server is running in test mode. So we just saw these parameters being used in the init of the client. So again, we sent a join request to the server, and the server sent back a join reply. Okay, so let's get back to our client though. Okay, so back in our client in the init. So that's the basic end of the init, and then the client's up and running. So back in the starts client, all of that just took place in start client right here when we loaded the module. And then from that module, we call run. And run is the main loop of the client. So let me get back to that. So if I go look at the run function, this function will never exit until the very, very end, until the game's over, or until the user presses Control-C. There is also the ability to exit out that way or closes the window. But besides that, this will loop forever. It is a while true loop. And this loop does effectively 3 things. Well, I guess 4 if you count all the details. And I have them listed here, but I'll show you where they lie in the code. The first thing it does is it processes any messages coming from the server. So the server is going to send us updates for our player. It's going to send us what's called a step message. And when we get that, we're going to have to update our screen. So we update our screen. Now, there's also other reasons to update the screen. So, for instance, if there's animated tiles and a tile needs to change what it looks like every 4 or 5 seconds, or sorry, every 40, 50 milliseconds probably is more likely, then we have to update the screen even if we haven't got a message from the server. So sometimes we have to do the update screen then. And then the other thing that we have to do is we have to see if there's any user input. Has a user click the mouse, click the keyboard, and we have to send messages to the server in that case. If those key presses are things we need to send to the server. For instance, if the user randomly presses the letter K, the K means nothing. I'm not going to send anything to the server. But if they press the space bar or click the mouse or move the mouse, actually, there's no mouse movement, it's just wherever they click the mouse. Those are the main things we send to the server. And then the final thing that while true does is it does what we call loop timing. And that makes sure that loop isn't just going like crazy. It's only going to run that through that loop once every 30th of a second or 60th of a second, whatever or 15th of a second, whatever the FPS is set to, the frames per second is set to for the game. and that's a command line argument. It defaults to 30 frames per second. When we talk about the server, we talk about that in terms of steps, but here we're talking about in terms of frames, because however often we go through that loop, that's how often we can update the screen. So if it's 30 FPS, then we're going to update the screen 30 times a second at most. Okay. So let's look at this in a little bit more detail. To start with, there's this idea of getting messages from the server. And again, so I'm back in the ClientPy, I'm back in the run method of the client. And I have a call here to the receive reply messages. So this is all built into the socket code, which is over here on the left. On the network code, there's a socket class in there. And that was created in the init above. You can go read the details if you want. But effectively what this will do for you, it will receive any messages that are coming in from the server and then call any of the functions that are related to that. What am I talking about? So let's look very quickly again at the messages. So if we look, so again, I'm in messages.py. So messages the server could send, for instance, the main one is a step message. So the server could send a step message. So what'll happen is when you make this call here, if there is a step message waiting, it's actually going to call another function here called message step. So you don't have to call this. What happens is, again, you call this method of the socket. If there is a message of type step waiting, this function will be called. This method of the client will be called. And it's going to call that with the message, which is a dictionary, okay, type, but also the IP port, all this information. And then what you can do is process that message and then return. You don't have to return anything. It's that simple. So here we're saying if the server IP port that I joined, where I joined the game, is equal to the IP port that sent this message, okay, or sorry, if it's not, then just return. I'm not going to process step messages that didn't come from the server. Otherwise, I'm going to save the step message. And I'm also going to invalidate my screen. So this basically just says that the screen needs to be updated. This screen valid until is the next time that the screen needs to be updated. And setting it to 0 is just in the past so far that it needs to be updated. So that's all we do when we receive a step message. And that's the only one I'm going to cover. There are other messages we can receive. There's a quitting message. So if the server tells us to quit, we can quit. And I'm not going to cover the UDP punch through. That's for more advanced playing the game over the internet. All right, so back to the client. When we receive messages, basically, I'm waiting to receive step messages. And I'm going to store those. I don't need to do anything with them. I'm going to do something with them when I update the screen. So that's all I do for receiving messages from the server. The next step here is, well, I probably need to update the screen. So I'm going to call update screen. I may or may not need to. The update screen function is going to determine that. So if I go look for the update screen function, so again, I'm still in the client, update the window. So what it's saying here is if I have a step message that's been received from the server, so that's the what I did when I received the step message, and if the screen valid until is less than the current time, then I need to update the screen. And when I receive a step message, I set that screen valid until to 0. So I'm definitely going to need to update the screen. Now, things get a little complicated, okay? Because we have dictionaries inside dictionaries inside dictionaries. So what I need to do now, and remember in the init, we loaded up all the maps. I need to figure out which map I need to draw, because I loaded all the maps. And the step message that I get from the server contains a pile of data. So if I go under messages here and I look, the step message contains all sorts of data, one of them being the map name, the name of the map that I need to render for this player, okay? It's also going to be the map the player's on. So what this is going to do, the map is, I'm going to go look in the maps I've loaded, that's a dictionary, and I'm going to load the map based on its name from the map name that was in the step. That's what that's saying. So if the map name was start map, then what's highlighted here was equal start. And then I would look in the maps dictionary for a map name start, and I would get the map object. And that's going to be a client map, by the way, object, just in case you're wondering. So with the loader for the client, it will return a client map object. Okay, so update layer visibility. So one of the other things that comes in the step message is a new layer visibility mask. So for that map that I just found, I'm going to set its layer visibility to be whatever the layer visibility is that came from the server. And again, that will set the layer visibility for all the layers, including tile layers and all of them. The next thing we need to do is compute the best map offset. So this is the offset to draw the map app. I'm not going to cover that. You can go explore that function yourself if you want, but it basically sometimes will scroll the map. You can see this demoed in the engine test. There's actually a huge map called, and maybe I'll show that right now. That's not a bad thing to show off. So if I run the engine test, if we go to the big map, oh, there it is, big map. As we walk, we see the map is scrolling. So that's the offset of the map. So that code is going to figure out what the best offset for the map is. Again, you can go read the details of that. And then the next thing we're going to do is we're actually going to draw the map. So we're going to blit the map. So the self screen is the window. We just computed the offset that we want to draw the map at. And we're going to provide the sprite layer. So the biggest thing that came with that step was a dictionary with the entire sprite layer that the server has. So again, if we look at what the server sent us, it sent us the layer visibility mask that we've used, and it sent us the map that we're on. Sorry, in the proper order, it sent us what map we need to draw, the layer visibility for that map, and a completely new sprite layer for that map. So whatever we just loaded off disk when we did the init and loaded up all the maps, we're going to ignore that sprite layer, and we're always going to use the sprite layer that's coming from the server, because that's where the real game takes place. So we're going to ask that client map object to draw the map, and here we're using the term blit. So blit just means blitter. Blitter is an old term. There used to be microchips built into computers called blitters that moved pixels around and did it very quickly. We don't need them nowadays. We have more advanced graphic cards. Even CPUs of today are faster than old blitter chips, but the term blit still exists. Pygame uses the term blit. You could use the term render, but render is a bit more formal. This is just moving pixels around, so we're just using the term blit. So the client map object will draw the map to the window with the offset. And that returns how long until it thinks that map needs to be redrawn. So when you have animated icon or animated tiles and things or other objects that time out, we need to know how long until we have to redraw the screen, right? Because we're going to use it up here again. So we're not going to redraw the screen until we know it needs to get drawn. So, if we receive a new step map, we set that to 0. But here, maybe 30 milliseconds from now, we need to animate a tile. So we need to store that as well. Okay, so we've done that. We've drawn the map. Now we also need to update the interface. Again, I won't go into this function, but this will draw any interface items. Actually, I'll look at that very briefly because there's very little there today. If we look at update interface, this is where things like action text and marquee text get drawn. So again, these come in the step message and they can get drawn to the screen. So there's a little bit of interface things that get drawn. And these are drawn relative to the screen, where everything else is drawn relative to the map. If you don't understand that, that's okay. But it also will draw all the test text if we're in test mode. So that's what the interface does. You can add things if you want to have a button in here or something else. This is where you'd add that. And by add it, I mean not in this file. You would subclass this client for your game and then extend the update interface method to add your own interface elements. And you can do that with all of these functions, by the way. That's why I'm explaining them. Okay, so that's update screen. That's great. So if we go back up to the run, so we're back up in the run method now. We want to process events now. So we have received messages from the server. We've updated our screen. Now we want to do process events. And I think this one will be a little further down, so I'll use find. Okay, so we're still in the client.py, and we want to process events. So this one's fairly simple. And we're using Pygame both to do our, Pygame's the module that we're using both to do our screen rendering, our underlying graphics. It's also the one we're using doing our underlying, getting keyboard mouse events from the user. So for every event, process the event. That's all that says. And here's the process event function. And so here we can see if the user changes the size of the window, we need to set our screen valid until to 0, because the next time we go through the loop, we want to draw the screen. If the user pressed, it did give us text input and it was a space, we actually send a message of type player action to the server. If they pressed key down for F1, F2, F3, these are actually some of the test keys that we send. So we send some messages for that. Again, this is that send message. This will go to the server. Mouse down is a little more complicated. So if we get a mouse down, we actually can compute where on the map, based on the current offset, the user is clicked, and we can send a message type of player move to the new destination X, destination Y. Now, this is all there is to send a message to the server. You just create a dictionary with the particular types in it that you want, key value pairs, and it will send it to the server. But if you go look back at that messages.py, these are the only message types that are allowed. So we were just looking at a move. So if it has type player move, you can only have messdes X and Y, and those have to be types int. So if we go back to our client, I see I have a dictionary. I have a type key with message type. Message type has been set probably to player move. Okay, I mean, there is some things here for the test, and I'll let you think about that, but it's probably player move most of the time. I have a move dest X key, a move dest X key with the value of where the user clicked, and the same for Y, and I have nothing else. So my message should be valid. All right, and that's message processing. So very simply, all it does is receive inputs. It might redraw the screen. Otherwise, it's just sending a message, if the input makes sense, to the server. Pretty straightforward. All right, so the last thing to talk about here is loop timing. So I'm just trying to get back to the run method. So I'm back in the run method. I'm back in that main loop. So in this main loop, what we have is, process events. We just did that. And now we're going to wait until next step should start. So all of the code after this, you can read it. It's a bunch of gobbledygook. But what it's trying to do is, if we are supposed to go through that loop 30 times a second, or 60 times, or 15 times a second, it's waiting until it knows that the next loop is supposed to start. So that is what all this code is doing. Occasionally, it will check to see if things are running too slow and log a line saying, hey, the computer can't keep up. It's actually, the loops are running too slow. I don't even have to wait. I'm actually falling behind. So it will log that. But at the end of the day, it computes the next step at. And when we're done all that, we go back to the top. Where's the sleep, though? Oh, there it is. Okay. There's the key thing. When we come down here, if we have time left over in this step, we actually, and again, when I say step, think frames per second, steps per second. It's the same thing. The server side is step, the client side is frames, but they're used interchangeably. So time sleep, we actually sleep. So we actually put this process to sleep until we're ready to go through the loop again. All right, so there's the client. Again, I'll talk about subclassing in a bit, but let's briefly look at the other class here that we've been using, which is the client map. And really, the client map is a very simple class. It's got a lot of code, but it's all just render code. So if I go look at client map, the init's fairly simple. It's basically calling the super init, and by the way, the client map inherits from the engine map. The engine map is the class that can load up all of the data for the map data that was output from tiled. So this class doesn't need to do that. It's done by its subclass. So I'm calling init on my subclass, which does all that work for me. I'm setting a few parameters here. For instance, I never render these layers directly. So that's just making a note of that. I'm setting up some default text, some graphic text things for various types of text. I'm doing some sorting of object layers and things. I'm getting some image buffers ready. It's all stuff related to graphics and just getting things ready. You can read through bits of the comments, but it's pretty repetitive. The one function I do have here is I have a set layer visibility. And this is something I need to do for my buffering of different images about whether or not things need to be re-rendered. So just like I have a timer or an indicator whether or not I need to re-render the map at all, that's something that exists in the client. Within each map, client map object, I actually have some flags saying whether or not I need to re-render parts of it, okay? And basically the bottom image is all the layers below the sprite layer, and the top image is all the image layers above the sprite layer. And then the main call that I make from the client is blitmap. This is the one that draws the map. So I need the destination of where it's going, the offset, and the sprite layer. And just to summarize this, I mean, there's some more sorting that goes on to make things fast. But effectively, I draw all the layers below the sprite layer, and then I draw the label text for the sprites. I draw the sprites themselves. I draw the layers above the sprite layer, and then I put any speech text on top of everything so it can be seen. And all of that time while I'm doing that, I'm always recording what the valid until is, and I'm putting that into an array of valid until things, and then I'm returning the minimum of that. So the map will be valid, and that's you saw that before in the client, that valid until being returned. So the map will be valid until that times out. So whatever the minimum thing is that we just rendered. And then everything else, I'm not going to go into it, but everything else in this file is rendering, sorting, working out buffers, blitting a particular layer, breaking it down into its bits. And the lower you go down, the more you get to smaller and smaller things. So here's how to blit a particular object. This figures out what type of object. If it's a tile object, here's how to blit a particular tile object, how to blit text. If we keep going, we'll see there's even blitting shapes. Yeah, so blit a round style object, blit a rectangle object, blit a polygon object, all of these different things. So this handles all of that. So you may want to subclass some of this, and you'll see an example of that in the demo with the under map to draw black circles and things like that. But most of the basic renderings here, and there's a lot of code, but it's all, you can follow through the code and understand it, I think, if you spend some time. But whether or not you need to do that is up to you. Okay, so the last thing to talk about is, I started this off by saying that you want to be able to subclass these. So let's talk briefly about how that's done. So if I look in the demo game, I will see a client and a client map. So the client is subclassed in this way. So engine client. So I am in source demo client.py, and I am going to subclass from engine client the client class, and I'm going to make a new client class. And basically the only thing I want to do here is I want to change the text format of the marquee text. So when the demo first starts, we use a fancy font, so run demo. I didn't let things quit before. Let me try that again. I broke something. Let me go fix this. So this is something I talked about actually in the maps video, is if you have a folder in the maps folder that does not contain a valid map file, like this one, which is empty, your server and clients will not start. So I'm in the source demo maps and I accidentally left the sky empty folder sitting there. So I'm just going to get rid of that. Okay. So run the demo. Sorry for that tangent. Okay. So this fancy font that you see here, what this is, I'm just going to close that. We don't need it. But that fancy font actually lives in the source demo font directory. So there's the old London font that, again, this is a free type font. Make sure that if you do that, you put it in the credits file where you got it from. The credits file, of course, lives under docs. There's credits, so make sure you document that. But what I wanted to do here is I wanted to take that marquee text and update it to use that old London font in a different font size and different colors. So if we go back and look at the client in the engine, we'll see that one of the things that it set up, I'm far too low down in the file, one of the things it set up in its init was this marquee text, which doesn't do much, it just centers the text, so which means that the marquee text is just going to use the default text otherwise. So what we're doing here is we're making the marquee text a little fancier. So when you use update on a dictionary like this, it will merge these parameters on top of the existing dictionary. So the old marquee text just had the center, and here I'm putting a whole bunch of font stuff on. Just for the sake of logging, I'm also outputting the doing some logging here, which isn't, I won't go into, it's not that important. So that's all we're doing to subclass. We're subclassing engine client. We're calling super on the super class, and then we're changing what we want to change. The same is true for ClientMap. So here ClientMap is engine ClientMap. ClientMap is what we're subclassing. We're calling init. Is all I'm doing? Yeah, all I'm doing is fonts for here. So here I'm changing the default text font and the label text font for the demo game, and that's all I'm doing. Now, just very briefly, within a map, you don't have to. Like if we go look under the start map, there is no client map, but you can also subclass under the a particular map. Now, in this case, I'm going to actually subclass from demo client map. So this class for this under map is subclassing from the games client map. The games client map is subclassing from the engine client map. So in this one, I'm actually doing the rendering of light circles. I actually cover this in a separate video, but I'm actually overriding or extending the blip-map call and actually adding in those light circles and doing all the setup for the light circles. But that's just giving you a look at how you're going to subclass. All right, that is the basics of the client code and how you might want to work with it. Just giving you an overview. Thanks.